Let's get a little heavy without the math. So let's create a graph this time. No function. We're just going to create a graph that has a domain of this interval and a range of this interval. You'll note that sometimes it has a bracket and sometimes it has a parenthesis. The bracket means that it's included. Much like when you graphed on a number line and you put open circles or closed circles, a bracket would correspond to a closed circle. It's an included value. But the parenthesis means that it's not included. Now, why would we have parentheses for infinity and negative infinity? Because infinity, negative infinity, we treat it like a number, but it is not a number. And so we don't really reach infinity. We approach infinity. That's another conversation.
You're mocking me, aren't you?
So what we're being asked to do is to create something that has an x axis, left and right, that goes on forever to the left, right? Negative infinity means I'm going forever. And then it goes to the right forever. So for example, if we were looking at the number line, this is pretty much what we're doing, right? We're going forever to the left, we're going forever to the right, because the domain is the x values. Now it could be a graph that simple if it weren't because of the range. But let me propose this to you, that as long as it's going to the left forever and the right forever, if all we worry about is the domain, then a lot of things can satisfy that condition. Something like this goes on forever to the left and it goes forever to the right. That would satisfy this condition. Remember our parabola? This is a wider parabola, but it goes to the left forever and it goes to the right forever. That would also satisfy this condition. But we got to make sure that our graph also satisfies this condition of the range. And the range is the y-axis. So what the range in this case is saying is that we can include 0, but then we go on forever. So we can include 0, right? But then we got to go up forever in this positive infinity direction. So I need a graph that goes to the left forever, that goes to the right forever, and that goes up forever, but it kind of has essentially a minimum at 0. Well, this might be actually a pretty easy graph if we think about it. Notice, does this graph go to the left forever? Well, the arrow indicates that it keeps going on this way. So it is going to the left forever. This is going to negative infinity forever. And then to the right, this graph is going in this direction forever, positive infinity. What about the range? It seems to go ahead and stop right here at 0. And so it is including this 0 as a minimum. But the question then becomes, does it go up forever in this direction? Well, look at these arrows, right? They're pointing not only to the right forever, but also upward forever. Like, do we know when this graph stops? No, it has arrows. We know that it stopped at 0, but it's going to go up forever and to the right forever in this direction. Over here, it goes to the left forever and up forever in this direction. There is no stopping with this arrow. This arrow goes on forever.
You're mocking me, aren't you?
What about our parabola that we've been talking about? Same idea, right? It has the range, the y-axis. It stops, it stops at 0 here, right? It has a minimum. But these arrows indicate that it goes up forever. It goes up forever. But not only does it go up forever, it goes to the right forever, and it goes to the left forever. Now, if you're really confused, you need to go back, pause this video, rewatch this part, problem 3. We're going to talk about more of this in the next video. But you're starting to, you've gone through many years of math, right? And it's getting to a point where it no longer is about doing the same thing 100 times. It's time to start thinking about math. Math isn't just doing, math is a lot of thinking as well. And so please take a moment to really pause to, think about problem 3 and other problems we'll show you with the graphs. What do these arrows mean? What does the graph mean? What is the graph really doing? How is this graph represent the domain and range?
You lose.
For your summary, how are domain and range related to input and output for functions?